What if thousands of acres of lush green forest suddenly petrified into silent, ghostly graveyards overnight? Across coastal regions and remote mountain valleys around the globe, strange landscape transformations are occurring. Vast stands of trees stand completely lifeless, their bark stripped away by time and elements. Local legends often refer to these haunting landscapes as ghost forests. To an untrained observer, these silhouetted trunks appear cursed or artificially drained of vitality. But beneath this eerie aesthetic lies a fascinating ecological and geological phenomenon. Across coastal regions and remote mountain valleys around the globe, strange landscape transformations are occurring. Trees that took centuries to grow are preserved in state of natural mummification rather than decaying away. How do these vast forests die simultaneously while remaining standing upright for centuries? What hidden planetary forces turn vibrant woodlands into pale, standing wooden pillars? Today, we look beyond folklore to examine the incredible science behind Earth's ghost forests. Prepare to uncover a hidden ecological transformation occurring right under our feet. The most prominent cause of modern ghost forests occurs along flat coastal plains. Dense freshwater forests of cedar, pine, and cypress depend on precise soil balance to survive. As local sea levels gradually shift, saltwater creeps steadily inland through groundwater networks. This process, known as saltwater intrusion, acts as an invisible environmental filter.
Tree roots absorb the high salinity water, disrupting their ability to transport essential nutrients.
The trees slowly dehydrate from the inside out, despite standing in abundant moisture.
As leaves fall and branches weather away, the high salt content acts as a natural preservative.
Salt inhibits the bacteria and fungi that normally decompose dead wood in tropical or humid climates. Consequently, instead of collapsing and rotting into topsoil, the trees remain standing like petrified pillars. Whole coastal bands transform into silver-gray woodlands that can endure for over a century. Satellite imagery tracking coastal change reveals these ghost forests expanding at measurable rates. They serve as stark visual indicators of shifting environmental boundaries between land and sea. This continuous expansion marks a profound shift in global coastal dynamics that scientists are monitoring closely. By analyzing the salinity levels, they can predict which coastal woodlands are next to transform. It is a slow, silent invasion, rewriting the maps of our coastlines year by year. But what happens when the transformation is not gradual, but sudden and violent? While saltwater intrusion occurs gradually, tectonic activity can create ghost forests in a single moment. Along active subduction zones around the Pacific Rim, tectonic plates store immense mechanical energy. During massive megathrust earthquakes, large areas of coastal land can suddenly drop several feet.
Geologists call this rapid downward movement tectonic subsidence.
Entire coastal spruce and cedar forests that once stood well above high tide are suddenly submerged in saltwater. The sudden immersion in brackish tide waters kills the trees within a single growing season. Fine tidal mud washes inland, blanketing the forest floor and sealing the root systems in oxygen-poor clay. This anaerobic clay layer slows decay down to a near standstill. Centuries later, these skeletal trunks remain rooted firmly in the mud flats. Radiocarbon dating of these submerged wood cores allows geologists to pinpoint historical earthquake events down to the exact year. These ghost trees act as natural geological seismographs, recorded in ancient wood. They hold the silent records of forgotten cataclysms that shook the earth long before modern instruments. This physical evidence helps seismologists map out the dangerous cycles of megathrust earthquakes. By understanding these rapid events, coastal communities can better prepare for future tectonic shifts. The dead forests stand as warning monuments, reminding us of the raw power beneath our feet. But the Earth has other, even more stealthy ways of creating these silent sanctuaries of wood. Away from the coasts, in high volcanic mountain ranges, an entirely different ghost forest phenomenon occurs. Around active volcanic domes, deep subterranean magma chambers release carbon dioxide and sulfur gases. Under normal conditions, these volcanic gases diffuse safely into the upper atmosphere through mountain breezes. However, small tectonic shifts can fracture subterranean rock, allowing dense gas plumes to pool in low-lying soil layers. Because carbon dioxide is denser than oxygen, it displaces the air pockets within the soil surrounding tree roots. Deprived of oxygen, root systems suffocate silently underground, while the canopy above appears healthy. Within months, acres of pine and fir trees turn uniform shades of rust red and pale white.
Centuries later, these skeletal trunks remain rooted firmly in the mud flats.
The sudden emergence of a mountain ghost forest provides early warning of deep volcanic pressure changes.
It is a striking visual reminder of how deep Earth forces directly shape surface life.
These high-altitude ghost forests show us that geology and biology are intimately connected. When the Earth exhales its deep gases, the landscape must listen and adapt. The silent sentinels of the mountains stand as markers of volcanic rest and restlessness. To the untrained eye, these dead zones look like tragic ecological failures. But nature rarely leaves a vacuum, and every end marks a new ecological beginning. As we move back to the wetlands, we witness the incredible cycle of natural regeneration. At first glance, a ghost forest seems like a landscape devoid of life or ecological purpose. However, long-term ecological monitoring reveals that these dead trees play a vital transitional role. As light penetrates the cleared forest canopy, specialized salt-tolerant grasses and marsh vegetation take hold. The standing wooden snags become essential nesting sites for migratory birds of prey like eagles and ospreys. Below the waterline, submerged root networks provide protected nursery habitats for young aquatic species.
The forest is not dying permanently. It is evolving into a thriving wetland ecosystem.
Eventually, wind, tides, and weather will break down the preserved trunks over centuries. Nature adapts to shifting conditions, turning one habitat into another with remarkable resilience.
Ghost forests represent a temporary bridge between terrestrial woodlands and vibrant wetlands.
This resilience shows that even the most stark environmental changes can bring forth new ecological riches.
Life adapts, morphs, and finds a way to reclaim every corner of our changing planet.
Every standing trunk is a monument to past life and a nursery for the future. Scientists are now recognizing the critical importance of protecting these unique transitional zones.
They are not wastelands, but highly productive buffers protecting our coastlines.
Without them, coastal erosion would accelerate, threatening inland ecosystems even further.
Thus, the ghost forests stand as guardians of the coast, defending the lands they once ruled. It is a remarkable testament to the resourcefulness of our planet's complex ecosystems. As we look to the future, understanding these areas is key to forecasting global landscape changes.
By reading the rings of the dead trees, we read the history of the Earth itself. The eerie beauty of ghost forests holds a wealth of scientific knowledge waiting to be deciphered.
From tectonic shifts and volcanic gas plumes to shifting coastal hydrology, they reveal Earth's dynamic nature.
These standing wooden monuments record seismic history, climate cycles, and environmental adaptation. They remind us that our planet's surface is constantly in motion, reshaping landscapes over time. By reading the rings of the dead trees, we read the history of the Earth itself. Nature leaves its history written not only in stone, but also in ancient preserved wood. Which geological cause of ghost forests surprised you the most?
Share your thoughts in the comments below.
If you enjoyed discovering the science behind Earth's mysterious landscapes, hit the like button.
Subscribe and ring the notification bell for new environmental science explorations every week.
Thank you for watching, and keep exploring the fascinating science of our planet.